Welcome to the second part of this talk looking at why maths. In the first part we looked at the benefits of studying maths, and in this second part we'll look at what sort of things studying maths will entail. So what are your options for studying maths further? First up, there's additional maths, which is a qualification that bridges the gap between GCSE and A-level, getting you started on calculus amongst other topics. Not all schools offer it, but if yours does, it's a very useful qualification. Then there's A-level mathematics, which builds on your GCSE work, extending things you've seen before like functions and algebra. The big new thing is this thing called calculus, the maths of motion. So that's the maths developed in the 16 and 1700s by Isaac Newton and Gottfried Leibniz to analyze movement. You'll also see many other things, for instance logarithms. For A-level further maths, you'll go broader and deeper. You'll look at matrices, which are used widely in animation and engineering, and you'll look at complex numbers, which are used in electronics and quantum mechanics, among other areas. If your school doesn't offer further maths, then don't worry, this is a job for the Further Maths Support Programme. As I mentioned in the first part of the talk, we were set up by the Welsh Government for this very purpose, because they thought that further maths was so important that every student in Wales who wants to do it should be able to do so. So I'll talk about what we can offer at the end of this talk. One thing I should make very clear, which is that maths belongs to everyone, irrespective of race, colour, gender, religion. So here's a sample of the diversity of mathematicians. At the top are Hannah Fry and Ira Chamberlain, who spoke in the first part of the talk. Then below we've got Catherine Johnson, who was one of the heroes of the enjoyable film Hidden Figures, which was about female black mathematicians who worked at NASA, and in fact astronaut John Glenn trusted Catherine Johnson far more than he trusted the computers at the time. He asked her to check the computer calculations by hand and said, if she says the numbers are good, I'm good to go. Next to her is John Conway, a famous mathematician. Below him we've got Mariam Mirzakhani, who was the first woman and first Iranian to win the Fields Medal in Mathematics, which is equivalent to the Nobel Prize. And to her right is Terence Tao, who's another Fields Medal winner. Okay, so that was what are your options. What sort of maths comes next? So in order to answer that, I'm going to take us through an example. So imagine you've been given the task of finding the box of biggest volume that you can make from a 20 centimeter square piece of paper using the plan shown here. So a first good idea is that we could do trial and improvement, or guess and correct. So we could make a box, find its volume, and then we could try another and see if it's got a bigger volume. However, once you're familiar with algebra, we can do something better. So once we're familiar with algebra, we can come up with a formula for the volume of the box. So here it is. So here in this diagram, if you imagine that you've cut a corner, a little square out of side X, then we can see that the box dimensions, the base of it is going to be square with 20 minus 2x on one side, 20 minus 2x on the other side, and then the height of the box when we fold up the edges is going to be x. So the overall volume is going to be the product of those three dimensions. So the volume of the box, V, is equal to x times 20 minus 2x squared. Now, why that is handy is then we can plot that formula for the box volume, and we can see by inspection that the maximum volume is when x is a little more than 3. Okay, so that's an improved way of solving the problem. However, once we do calculus, which we'll see at A level, we can do better still. Now I'm going to switch to GeoGebra to explain how that works. Okay, so I've got the volume curve, this red line again, and x is going between 0 and 10. Okay, now you'll have seen the idea of gradients of straight lines. Well, there's a way of defining the gradient of a curve at a point by saying it's the gradient of the line that just touches the curve, the so-called tangent. So we could say the gradient of the curve at this point here is the gradient of the line, which turns out to be 221.91. And so we can see that the gradient of the curve on this side towards the left is positive. And if we go over the other side, the gradient on the other side is negative. And if we go to the top, then the gradient is 0. Okay, the gradient is 0. And that is the key idea, that at maxima, and also this minimum point here, at maxima and minima, the gradient is 0. So if we now switch back to the slides, okay, that's idea 1, was the gradient being 0. Idea 2 is that calculus gives us a way to take a function like the function v and to get a new function which you can call dvdx or v dashed or anything you want. You call it Bob if you want. And the important thing about our new function Bob or v dashed is that it gives us the gradient at any point on the original curve. So I'm not going to explain how we find this function, but I'm just saying that calculus will enable us to get it. Okay, and this is the function. Okay, and so now we can combine those two ideas to make a really useful one. So the first idea was, if you remember, that the gradient is 0 at the maximum point, and the second was that we've got this new function which will tell us the gradient of the original curve at any point. So here's the deal. If we find the places where the new function is 0, we can find the maximum. Now, what we can see here is v dashed, our new function, is actually the product of two terms. So it's only going to be 0 when one of those terms is 0. And if 20 minus 2x is 0, that means x is 10. We're at this point here, which is a minimum, so that's not the one we want. If 20 minus 6x is 0, then that means x is 3 1/3, and we're at this point, which is the maximum. So using this, we can solve that. So the gradient is 0 when 20 minus 6x is 0. So the maximum box volume is when x is equal to 3.33 centimeters. So again, don't worry about the detail here, because you'll be able to grasp this when you're actually taught properly slowly how to do it. But what I'd like you to take away is the big picture, which is calculus is giving you a truly awesome tool, the ability to optimize. The world is crying out for minimizing the cost or the time or the resources in something, or maximizing the efficiency or power or strength, and calculus enables us to calculate these very answers. Okay, so that's a sort of idea of the sort of maths that you would carry on doing at A level. What about when you go to university? What sort of maths do you do there? Well, it will depend on what course you're doing. Your maths may vary. A first point to make, though, is that if you've done further maths A level, you'll be at a very big advantage if you're studying STEM-based subjects, because they will be using the maths that you've studied. So typical topics that you might study include differential equations, which is another wonderful tool that calculus gives you. You'll do some of these at A level, but they do crop up everywhere when we're trying to solve real-world problems with quantities that change. So here is an example from ecology, the Lotka-Volterra predator-prey model. Now this came about when someone wondered why stocks of fish seemed to oscillate, and by modelling the situation using differential equations they came to realise that this was a natural occurrence. So what I've modelled here is a population of rabbits and a population of foxes. I'm not going to explain these equations, though they can be relatively easily explained. What I just want to point out is when you use these equations they show you the populations of rabbits and foxes, and what's going on is that when, for instance, the number of foxes is very low, then the population of rabbits soars, which means it's good for the foxes and their population will start to increase as they eat the rabbits. As there tend to be more and more foxes, the number of rabbits will drop rapidly, and then it suddenly becomes hard if you're a fox because there's not much to eat, and your numbers will start to drop as well. So you get this cycle which repeats with the number of rabbits and the number of foxes oscillating. Now, obviously this is a bit overly simplistic, since in real life there are usually many populations interacting. We've just got two here. However, it does exhibit and explain the oscillating numbers that are actually observed. So differential equations are used to model all sorts of changing situations. So not just population dynamics, but in physics and engineering they'll be used to model things like heat flow. If we combine calculus with something else we study at A-level, vectors, we get a topic called vector calculus. So that's something you might study at university. An example of it is the equations that James Clerk Maxwell came up with, the ones which bear his name, the Maxwell's equation, which describe, amongst other things, how light and radio waves behave. So the equations here, although the symbols will be unfamiliar, these are also differential equations. They're partial differential equations. If you study physics or engineering or maths at university, you'll be taught how to understand these. So don't be at all fazed by these symbols. I mean, this is something you'll learn at university. And this vector calculus is also used to understand how fluids flow and what makes aeroplanes fly. Another topic that you've already seen some of, and you'll see more of at university undoubtedly, is probability and statistics, because they're super useful for describing complex situations, like where we help biostatisticians work out if medicines really are better, but also helping engineers make systems that are robust and reliable. So for example, one offshoot of this is something called information theory, which gives us error correcting codes which make our mobile phones work, gives us ideas about how we can compress files on computer networks, things like that. If you study maths, then you're going to be studying all these topics, but you'll also study things, abstract ideas, like something called group theory. Now it's hard to explain briefly, but it's a study of the science of symmetry. So it would enable you to prove and understand the fact that there's only actually 17 possible symmetry patterns you can have when you're designing wallpaper. So I'm not talking about the designs, I'm talking about the symmetries of them. Okay, so that's given us a flavour of the sort of maths that we might see at university. What do different universities require for their courses? What are their entrance requirements? So let us find out. So here I've got the Guardian league tables. Other league tables exist, and if we choose a subject area, I'm going to choose maths, but you can choose whatever you like. And if we then search, it says it's got 1,027 courses across 85 institutions, so plenty to go round, and they've ranked them in an order they think best. So you've got universities you'd expect, Oxford and Cambridge and St Andrews. It's possible that the ranking given here might not correspond to the ranking that other people would give, and in particular that it might be that the best university for you isn't necessarily the highest rank. I would strongly recommend that you try to find somewhere where you think you're going to be happy studying for 3 or 4 years, and I'd recommend visiting it and speaking to the staff and the students, and also looking at the course to see if it covers the things you want to do. If you want to do a year abroad, does it offer that? So there's loads of things to investigate. This is just information. Now what I'm going to do is I'm going to scroll down because I want to look at a university. So I'm actually going to, if I can find it, I'm going to look for Leeds. I don't know anyone who's done maths at Leeds, so I'm not recommending or not recommending it. I just wanted to find it and explore it. Okay, so if we choose the BSc in maths, here we have it, and we can see what they offer. So maybe we want to find the entry requirements. In fact, that's what I was going to have a look at. Oh, my laptop is getting upset. So let us have a look at that. It's saying that we need to have A, or we could have an A star and a B. But the point I wanted to show you was that actually if you have further maths to do this maths degree, they reduce your grade. So you'd have 2 A's and a B instead. And I know Swansea do that as well. So what I have here now are a couple of slides from my own university, Swansea, but what I would like to say before showing them is that you need to find something that works for you. As they say at the BBC, other universities are also available. So first up, we've got a slide about the newish degree in actuarial science at Swansea. If this is of interest to you, then I suggest you pause the video and have a look through the details here. We've also got a snippet of a presentation from a former Swansea student, Amy, who is now training to be an actuary. So let's hear what she has to say about what being an actuary involves.
All right, so hello everyone. My name is Amy Sutherland. I work at Hymans Robertson, and I'm currently training to be an actuary. As Charlie said, I did a Masters of Mathematics at Swansea University between 2010 2014. So I'm hoping today just to give you a bit of a flavour of what an actuary does, and then also something that you might be able to look into as a career after you finish a mathematics degree. So firstly, I'm just going to talk a little bit about what an actuary does do. So as Dr. Wright said, actuaries do work in insurance, and we also work in pensions, investment, banking and corporate finance. So there's lots of things you can get involved in, and particularly once you qualify as an actuary, there's an absolute ton of avenues that you can take. So an actuary tends to look at risk events and understand the probability of various things happening. For instance, COVID or different financial market events such as a recession. So we look at the probability of those things happening, and then we also look at the financial impact of that on, say, companies or clients. So for instance, I work with a lot of pension schemes to understand the financial impact of things. So some of the skills that you need to have to become an actuary, obviously it's very mathematical, so good maths and analytical skills, but it's also really crucial that you've got good communication and management skills as well. So a lot of the work that I do is taking all these really, really heavy mathematical topics and statistical modelling, etc., to people that don't even necessarily have a GCSE or A level in mathematics. So they really don't know any of the maths behind it, and I still have to get across to them sort of what the impact is, what the cost is, what they need to do to make sure that they're in a good situation.
So we're coming to the end of the talk now. You know from the first part why taking maths further is a great idea for you. It helps most jobs and many subjects, will give you sought after skills and can be a lot of fun. You also know that you can do A-level maths and A-level further maths. Now, good reasons for doing A-level further maths are: 1, you like maths and aren't afraid of putting the necessary work in. 2, if you plan to do a university course that needs maths, then in doing further maths, you'll have done twice as much preparation, which will make the transition to university easier. And 3, some universities give lower offers if you've done further maths A-level. So have a look at universities you're interested in and find out if that's the case. So the final question here is for you to decide, what are you going to choose? Here are some resources to help. So first up, we've got under jobs, Careers Cast, which is an American website. Have a look at their top 10 best jobs of 2019. 6 of these are data scientist, statistician, information security analyst, mathematician, operational researcher, and actuary. So 6 out of 10, and they're all big users of maths. Now, Maths Careers gives you more information on what you can do with your maths, and that's where we took the profile of the climate scientist that we mentioned in part 1. Now, thirdly, the OR Society made one of the videos we saw bits of, and when I spoke to the woman who does their outreach to get permission to use the clips, as well as saying yes, she told me they offer free membership for students who are 16 or over. Now, for universities, I've just given the Guardian list here, but there are others. Maths. Well, maths is the whole point of studying maths, and so of the resources I've put here, I really like the Numberphile video and Matt Parker's videos, so you may want to explore them if you haven't. The Enrich website aims to enrich your study of maths by showing you some interesting things, so you may enjoy that. Also, the UKMT, the UK Mathematics Trust, is very keen to promote the fun and skill of problem solving, and they have free problem sets that you can try your hand at. Under further maths, I've pointed you to the WJEC website, which has the detailed specifications of what you'll learn at A-level for both maths and further maths. And also our website is here, furthermaths.wales.org. Okay, so here is our website, furthermaths.wales. The site is evolving, so may look different slightly when you come to look at it. There are sections here for students and sections for teachers. There's a section on events, and if we go down and let's have a look at what student events are on currently. So if we scroll down, we see that at the time of making this video, we'd got a series on solving unusual mathematical problems. We've also got a series on the so-called 6th term entrance paper that Cambridge use for their maths students. Okay, if we go back up to the top now, let's see what else we've got. Resources. So let's choose Mathematical Worlds. So Mathematical Worlds was a series that we ran, an enrichment series we ran in summer 2020. Researchers from around the world, so Australia, America, Germany, talked about different mathematical areas. Now this here is actually a guide aimed at teachers, but hopefully you'll find it useful as well. It gives a brief description of each world and what sort of level it's aimed at. I would say all the talks are good, but perhaps my favourite is this Mad Vet world I mention here, so you might want to have a look at that and see if you enjoy it. Okay, let's look at our YouTube channel. So if you search for FMSPW on YouTube, you should find it. I've selected our playlists and there's a good number. So here, if we go to the top, let's go to the top. Here we've got solving unusual mathematical problems, the playlist for that. We've got beneath it the mathematical worlds playlist that I mentioned. This video that you're watching now lives in careers in mathematics. If we go down, okay, we've got some super flipped classroom videos here, so they go through various topics in A-level maths very clearly, very well explained, so you might want to have a look at that. Here are a set of videos which go through solving various exam questions, so again a very useful resource. What else have we got? Okay, we've got revision videos here, so on further maths topics. So those also go through exam questions, but they actually revise the whole topic. So plenty of stuff. We hope you find useful things here. We'd welcome any comments or feedback you have on how to make it even better. Okay, and then finally, the videos I sampled from are listed there if you want to investigate them further. And I also said at the end of the talk I would tell you about the things that we offer. So here they are. So one, we have self-study materials for additional maths, A-level maths and A-level further maths. We saw some of them on the YouTube channel. Two, we offer AS or A-level further maths tuition if your school doesn't offer it. So no, this is arranged through your school, so there is no charge for students or parents. And if you want more information, have a look at the booklet link mentioned there. Third, we organise revision and study days online or at the Welsh universities. We've got mock interviews for university applicants that we do. Now, STEP AEA, MAT and TMUA, these are all maths exams that are used by various universities to help their entrance processing. But the key point is that they are all about solving problems, so not just demonstrating your mastery of techniques. So coping with uncertainty and switching to being energized and excited when you face an unknown problem rather than crushed and broken is a key skill that you'll learn by preparing for these. So we're keen to help and support you in doing that. And then finally, enrichment material. Again, we've seen some of that. So there's the mathematical worlds and the bridging to uni resources. And separately, we also run solving unusual mathematics problem, a course on that. Okay, we've now come to the end of our journey together in this talk, but in other ways, yours may just be beginning. So I wish you a very enjoyable one and every success in your future studies.